All right, so 16N is general solutions of circular functions. So far we have found solutions to circular functions like our sine graph, our cosine graph, our tan graph. The solutions are just what? The x-intercepts. Yeah. So what we're going to do in this topic is to find the general solution. So usually we find like x-intercepts between 0 and 2 pi. Find all of those ones. A general solution is like every x-intercept, because you know how the sine and cosine graph, they keep going? Oh, yeah. And the tan graph, they go on forever. So this is like a general, like every single x-intercept.
So it's not one number.
Up to infinity and down to negative infinity. Yeah. If sine of x equals a, then x equals 2 times n times pi plus the inverse sine of a. Or 2n plus 1 times pi minus the inverse sine of a, where n is an element of z. What's z mean?
Oh, z.
Positive.
Integers.
Integers, yeah, positive whole numbers.
Right.
Right, including 0. And a is between -1 and 1. Right, so for this equation to work, that a has to be somewhere between -1 and 1. If it's 2, it won't work. Okay. Next one is cosine x equals a. Then we get the general solution x equals 2n pi plus or minus inverse cosine of a. So it's two solutions. There's a positive solution and a negative solution, the plus and minus, where once again n is a positive whole number and a is between -1 and 1. And the last one is 10. And our general solution is x equals n times pi plus inverse tan of a. Where n is a positive whole number. And this time a is just any number within the real set. Let's go into an example. First one, start off with an easy one. Cosine x equals 0.5. So obviously it's a cosine graph, so our solution is going to be 2n pi plus or minus inverse cosine of a. Is a, what is a in the question? Good. Is it between -1 and 1?
Yes.
Great. So it'll work. So we're going to plug that into this equation.
What if that wasn't between -1 and 1? The question is not working.
You wouldn't be given a question like that. Yeah. 0.5. So you're doing is sub in your a. Now, what is inverse cosine of 0.5? Don't know. We don't have a calculator in a test. We ask ourselves, what angle gives us 1 over 2.
Oh,
When
5
it's-
4.
No, if we've got them.
No,
Four.
no, 5 over. No, 5 3. 5 6. 1 root 6.
Pi on 3. Root 3 is opposite. Pi on 6, 1 and 2. So we need 1 over 2 when it's adjacent over hypotenuse.
No, it's not true, is it? Yeah.
Adjacent, 1 over hypotenuse 2. 1 and 2. So it's pi on 3. So
Miss, how did we figure out it's pi on 3?
you say for what angle, pi on 3 or pi on 6, gives us 1/2 when it's adjacent over hypotenuse, because cosine is adjacent over hypotenuse. Yeah. So then all we have to do is just change that bit of the formula. So we've just changed inverse cosine 0.5 into pi on 3, because that's the solution. And then from there, all you have to do is simplify your fraction.
Do we 3?
So we're going to, make a common denominator over 3. So that gives us 6n pi on 3 plus minus pi on 3. Yeah. 6n pi plus minus pi over 3. Can we take out, is there a common?
6 and 3.
No.
Because it's 6
So
times.
what's it?
Isn't it 6 times n min?
No, you can't simplify the 6 and the 3 because there's nothing in front of that pi. What's a common factor?
What's the n value again?
N can be any positive whole number. So n stays in there. Okay, what's the common factor of 6n pi and pi?
Pi.
Good, so we're going to factor out the pi. 6n plus minus 1, factor out the pi, on 3.
Is that
Last little bit, you say n is an integer. That is it.
what is the special ES?
That's an element,
What makes you say that?
because that's the rule. In the rules that you just wrote down, n is always an integer. So you just have to state that. Yeah.
Yeah, sure.
Okay, root 3 tan of 3x equals 1. Right, now in our formulas, it says tan x equals a. So what do we need to take over the other side? The root 3, yeah. So tan of 3x equals 1 on root 3.
What do we do about 3?
Good question. Instead of x equals, like in our formula, we're just going to write 3x equals. Because our formula is tan x equals a. So x equals 3x and a equals 1 on root 3. So, yeah, pretty much. So our general solution was this one for tan. So then you just plug in your 3x and your 1 on root 3. So put 3x here, n pi plus inverse tan of 1 on root 3. Everyone following along so far? Yep. And then we do the same thing. So what angle gives us 1 on root 3 when it's opposite over adjacent? Let's have a look. Pi on 3, pi on 6, root 3 is opposite the 3, 1 and 2. opposite over adjacent. Pi on 6. Very good. So 3x equals n pi plus pi on 6. Let's get a common denominator. 6n pi on 6 plus pi on 6. We'll simplify that. 6n pi plus pi all over 6. What's the common factor of the top?
Pi.
Yep.
Pi. 6n plus 1 plus.
And, oh, whoops, sorry, 6n plus 1 pi over 6.
Yeah.
Divide by 3. And remember, when you divide a fraction, use times the bottom. So we get, yep. And don't forget, n is an integer.
Maybe
A sign, yep.
yeah.
2 sine x equals root 2.
Divide by 2.
Yes. Sine x equals root 2 on 2. Yes. So it's x equals four, x equals 2n plus 1 pi minus inverse sine of a. Right, so we get 2n pi plus inverse sine of root 2 on 2, or 2n plus 1 pi minus inverse sine of root 2 on 2. Now, what is inverse sine of root 2 on 2? It is not commonly one of the triangles that we use. It is, it's just one of them has been multiplied by a scalar. It's been multiplied by a number, every side of the triangle. It's always been a thing.
Oh, really?
Yeah. Remember, you can enlarge the triangles as long as you multiply all 3 sides by the same number, or you can shrink them. Because remember, your trig, sine, cos, and tan are just ratios. They're not actual lengths, they're just ratios. Remember, a ratio you can enlarge, or you can make smaller. Any ideas? I'll give you a clue. Right, we're talking about sine, so opposite over hypotenuse. What do we multiply our triangle by? So,
Times what? 2.
what do you say?
2.
Not quite.
4.
No.
If we multiply everything by 2, you'd get a 2 in this point and a root 2, or 2 root 2 here.
Root 2.
Yeah, if we multiply this whole thing by root 2, we now get root 2 here, root 2 here, and root 2 times root 2 is root 2 squared, which is
2.
2. Right? Opposite over hypotenuse. Yeah. Yeah, because root 4 is 2. Yeah, you can do it that way. Right? The other way that you can think about it is think about opposite of like rationalizing a third fraction. So if we've got root 2 on 2, you can multiply that by root 2 on root 2, which gives you 2 on the top, 2 root 2 on the bottom, which you can simplify to 1 on root 2, which is the triangle that you know. Maths. Crazy. Let's just get rid of that. Okay, so yeah, it's pi on 4. Right, so we'll just I'll get rid of this. Keep it neat. Yeah, we'll write it up here. So 2 root 2 pi on 4. Okay, so we get 2n pi plus pi on 4, or 2n plus 1 pi minus pi on 4.
Miss, I decided 1. Isn't it? No. 2? No. Don't you times it by root 2?
No, we were just with this. Oh, sorry. Yeah. These should be roots. That should be 2. Sorry. Doesn't change what we just did. It's still pi on 4. Okay, and then all you have to do is simplify. So, common denominator. 8 n pi on 4. And some of them will, yep. Okay, what's a common factor of the top numerator?
8n plus 1.
5. So 8n plus 1 pi.
Right, that one's factorized as much as possible. So we say n is an integer. And this one, a little bit trickier. Might factorize out expand out the brackets.
Plus 1 over 4.
Yeah, so it'd be, right, 8n
Plus 4.
times pi plus 4 pi. Right, because you're multiplying everything by 4 and multiplying everything by pi. Essentially, you're multiplying everything by 4 pi. Yeah. Minus pi over 4. Okay, 4 pi minus pi is, if I have 4 pi's, I take away the pi, I got 3 pi's. 8n pi plus 3 pi over 4. Take out pi, yeah. 8n plus 3 times pi over 4, where n is an integer. That is it. Now, the only other thing you need to know is if you get a question like, what are the first 3 positive solutions?
We sub into n, so like 1, 2.
Yeah. So you choose a value of n, usually start with 0, 1 and 2, and you just keep going until you have enough solutions, and you just pick the first 3 positive ones. It won't always start with 0. Like it could start with -1 or 1, but it'll be somewhere around 0 most likely. Do we need to do an example of that?
Yes.
Okay.
You just sub in 0 to 9.
All right, so for example, the very first question that we did, the cosine one, we got this solution. And what I want to know is the first 3 positive solutions. So I'm going to pick n equals 0 and sub that in. So we get x equals 0 plus or minus 1 pi over 3. Yeah, so that's just plus or minus pi on 3. Right, now I'm going to pick n equals 1.
So 7 pi or 5 pi.
So you get, 6 plus 1 is 7 pi on 3 or 5 pi on 3. So we've got 4 solutions. We've got pi on 3, negative pi on 3, 7 pi on 3, and 5 pi on 3. So which one of those are the first 3 positives?
Pi on 3 and 3 pi on 3.
Yeah, everything but that negative pi on 3 because it's negative. We're looking for positive. So our first 3 positive solutions are...
n equals 0, n equals 1, n equals 2 to get 3.
You just keep going until you've got enough solutions to satisfy the question. Yeah, so if it said the first 10 positive solutions, you just keep going, n equals 1, n equals 2, n equals 3 until you have enough solutions. Yeah, so you get pi on 3, 5 pi on 3, and 7 pi on 3.
Will it ever ask for negative solution? Like,
It might.
If it included negatives as well,
Mhm.
how do we determine if it's the third one is 7 pi on 3 or 5 pi on 3? Is it just the smallest number?
Yeah, in order. Do them in order. Yeah. 5 pi on 3 is smaller than 7 pi on 3.
So that would be the third one if we include negatives.
Yeah. Yeah. Okay, and that is it.